Hi everyone, today's lesson is on trigonometric inverses. So let's get started. Our objectives is to find the exact value of inverse functions. We're going to use properties of inverses to find exact values of your composite functions, and we're going to be graphing some inverse functions. So what I would do is I would start off with maybe possibly even freezing the video for a minute and using Desmos, draw the graphs of the following inverses. So what I asked was that when you looked up on Desmos is a computer, it's on your computer, it's a website that has a graphing calculator and as well as graphing on it, which is pretty neat. But remember our sine function that starts at 0, comes up, goes down, and ends at 0? Well, imagine if I were to draw in my y equals x axis like that, okay? And I were to reflect this graph, my sine wave, over that. What I would get is this, and this, by the way, and I'm talking about continuing this would continue like this, right? All right. So, and I were to reflect this. What would happen is this graph would do this, right? It would look up this way, and then this side would actually come down this way. All right. Similarly, with my cosine wave, if my cosine wave starts high, comes down, and then ends high, and I were to reflect it across my y equals x axis, this graph would be reflected, and it would look something like this. Okay, we flip over. Likewise, with my tangent line, tangent looks like this. Okay. And if I were to reflect it across my y equals x axis, which goes like this, my new graph would do this, and it would do this. Okay? Those are what we call inverses. This is for arc sine, arc cosine, and arc tangent. And when I say arc, when I'm saying arc, I'm saying ARC tangent. That's what I'm saying. I'm writing this, but I'm saying that. So what ends up happening is these are the graphs of my inverses, okay? And remember that we are interested in functions. And in this case, I want you to think about what would happen as this line continues to go down, right? What would happen there? Well, as soon as it turned this corner here, it would stop being a function. And so what we have is what we call restrictions for our inverses, because this, of course, would keep going down, right? This would keep going like this, okay? And then as soon as it turned this corner, now it's not a function. It's not going to pass the straight line test, right? So you're not going to have that be a function unless you restrict it. And so what's going to happen is we have restrictions, meaning this value down here being negative pi over 2, this value up here, pi over 2, okay? For here, this value here is 0, and this value here being pi. And down here, we have our asymptote flipped also. So this is going to be negative pi over 2. This value up here, pi over 2. Those are our restricted domains. That's what we call that, is a restricted domain, okay? So we do have some notation. I was just saying what I said, arc sine. I write arc sine like that. Okay, remember that x is an angle. So whenever you see something like this and it says, arc sine of that value, I am looking for an angle. That's what I'm trying to find. I'm looking for where my angle is 1/2. So I'm looking for an angle. That's what I'm looking for. So meaning, if I say, what is sine of, let's say, 0 degrees. If I said, what is sine? See how I don't have that arc there? I don't have this inverse here. That's not there. This is asking for an angle. This right here, without the arc, is asking for a numeric value. That's a number. That's going to be a value. Okay. So which inverse would be correct? So basically, Basically, what's happening is if I were to graph this, okay, and I'm asking myself, where is sine 1/2? Remember, all students take calculus, okay? All are positive here. Sine is positive here. tangent is positive, cosine is positive. But what happens here is when we think of this arc sine, where is sine a half, all right? What we have is a positive value, positive 1/2. So it's either in the first quadrant or it's in the second quadrant, okay? Where is sine a half? Now, remember, inverse trig function, see the function part of the word? For it to be a function for sine, okay? Sine only can be happening in its restricted domain from negative pi over 2 to pi over 2. That's it. So if I'm from here to here, and those are my choices, and this is a half, which is positive, this is the quadrant that I want to use. Not this, definitely not these, because they're not in my restricted domain. So for arc sine to be a function, it has to be in this restricted domain. And for sine, it's first and fourth quadrant. Okay, so now you're thinking, well, now it has to be in the first quadrant because it's positive. So yes, it'd be in the first quadrant. Restricting the domain of functions, a function's 1-to-1. If it's 1-to-1, it does have an inverse. If a function is not 1-to-1, then we can do what's called this restrict the domain. So it can be 1-to-1. And if you notice this, see our restricted domain, negative pi over 2 to pi over 2. Okay. So restricting the sine function. So basically what we're doing here is for sine, it's going to go up here. It's going to come down here. So our restricted domain here is, again, negative pi over 2 to pi over 2. Okay. So that's our negative pi over 2 to pi over 2. All right. And so what ends up happening here is that's our restricted domain. And then values on the left and right are negative 1 to 1. Okay. And that's, so what I want you to do here is I'm going to actually fast forward to the next screen because I want you to be able to see all the different restrictions. So for cosine does this and goes from 0 to pi. Okay. Also negative 1 to 1. And tangent going this way. Okay, this is my arc tangent. This graph here is my arc cosine graph. And this graph here is my arc sine graph. Now, I didn't graph the wave for sine. Sine does this, right? Goes up, comes down, and ends at 0. Likewise, it'll come down and then go back up. That's where you see the reflection across the x equals y axis. For cosine starts high, goes down, comes back up, does that. And also for tangent, does this, you'll see. If I have the y equals x axis, see how it's a reflection across that value. Now, what this does here is this tells me for my arc sine, arc cosine, and arc tangent, all my restricted domains and my ranges. So remember that if you have sine and you're asking what's the domain and range, these are reflected, okay? These are reflected. So if y equals sine of x domain is going to equal to my arc sine range. My y equals sine range is going to equal my y equals arc sine domain. So remember how those are equal to each other. And the last thing I wanted to say was for this, there are additional functions or domains for secant, arc cosecant, arc cotangent, and arc secant, but we're not covering those for this chapter. We're only going to be covering the inverse trig functions for domain and range. Summary of restricted domains, again, just talking about the sine. So let's look at that. Sine is going to be from negative pi to positive pi. So that's going to be these values here, pi over 2 to negative pi over 2. Cosine is going to be from 0 to pi, so 0 to pi. For tangent, it's also negative pi over 2 to pi over 2. So we have negative pi over 2 to pi over 2, and those are inclusive. So we're starting off with this example. The example says, find the exact value of arc sine of 1. where is sine 1? That's asking me for an angle. That's what they want to know. Okay, so where is sine 1? Now remember, we're looking for a restricted domain for our angle. Our angle has to be in this quadrant or this quadrant. Now for sine to be 1, for this here, from here to here, think about this. It's not going to be one of these angles. It's going to be one of my, on the axis. Now this value here, 1, 0, 0, 1, 0, negative 1. And so what you're thinking is it's definitely not this one, not that one, it's 1. So where am I at? It's at pi over 2. That's where sine equals 1. We have 4 of them. So what I would suggest that you do is set each one. And so let's do that. Let's split each of these up. Let's see. I'm going to draw a little line across here and across here. And then let's work on each one of these. So the first one says, where is, that's what that says, where is. And what I'm looking for is an angle. So where is sine root 3 over 2? But remember, it has to be in the first and fourth quadrant. So it's pretty easy to eliminate things right away. See how this is a positive root 3 over 2? Can't be in this quadrant because sine is only positive in the first quadrant. Now sine is opposite over hypotenuse. So where are you? You're at root, where is it? It's right here. So remember, across from the root 3 is 60 degrees. So this must be pi over 3. 60 goes into 183 times, so I'm at pi over 3. This is saying, where is tangent root 3 over 1? Now remember, tangent is in the first and fourth quadrants just like sine. So this is again positive, so it can't be in that quadrant. So where is tangent? Root 3 over 1. So tangent is opposite over adjacent. So again, we're at 60 degrees, right? Which is pi over 3. So the next problem is saying, where is cosine negative root 3 over 2? So where is cosine negative root 3 over 2? Remember, cosine's restricted value goes from 0 to pi. And so because this is negative, this is not going to be the quadrant because that's positive. So we're over here in the second quadrant, right? From here to here. And where is it? So cosine is adjacent over hypotenuse. There's 1. So across from 1, is the 30-degree reference angle, which is pi over 6. Now, but to get from here to here is 5 pi over 6. Okay. Where is cosine 0? Remember, cosine, again, has to be from here to here. Inclusive, brackets, it's inclusive. This value here is 1, 0, 0, 1, negative 1, 0. Remember how it goes cosine, sine? So for this value right here, where is cosine 0? Cosine is 0 at this value here, which is pi over 2. Okay, so we have 3 more values here. So let's draw another line going across. 3 on top, 2 on bottom. Let's see how we do this. All right, so for the first one, it's saying, where is cosine negative root 2 over 2? So again, cosine, first and second quadrant. Because it's negative, it's going to be in the second quadrant, which means that it'll be over here. So we're going to draw a little triangle here. Cosine is adjacent over hypotenuse. So we know that's a 45-degree reference, okay? And so what that means is that because it's negative, and this is from here to here, in that area is going to be 3 pi over 4. This one is saying, where's tangent? Root 3 over 3. So again, tangent only can be in first and fourth quadrant. And what you do need to know ahead of time is, how did this happen? How did you get root 3 over 3? That right here came from 1 over root 3, right? And so we know that's positive. So here it's negative. So you can't have that being in a negative value. So it has to be in the first quadrant, opposite over adjacent. So this is my 30 degrees. So where I'm at is pi over 6. This one is saying, where is sine negative root 2 over 2? Now keep in mind, sine can only be in first and fourth quadrant. but negative root 2, so it can't be in the first quadrant because the first quadrant sign's positive. So that limits us to being in the fourth quadrant. And we know, again, root 2 over 2 is a 45-degree reference. So one of the biggest mistakes that kids make for these problems is they try to get around here like this, going, oh, that's 1 3/4, right? Okay, that's not going to happen because remember, sine has a restricted area. It's from here to here. You can't go outside of that to get here. You can't go around like that to get there, okay? That's not going to happen. So you can only go from here to down. So what that means is you have negative pi over 4, okay, to get down here, but only stay within our restricted area, which is from negative pi over 2 to pi over 2. This one is saying, where is tangent negative 1? So we know where tangent is 1. Tangent is 1 at 45 degrees. So we know that because this is negative. And remember, tangent is our restricted areas are from first quadrant into fourth quadrant. So tangent is negative 1 down here. And so this must be a negative 45 degrees. Again, we're in radians. So we're going to say negative pi over 4. And for this last one on this page, you have where is sine negative 1? So sine, again, fourth quadrant. It's our restricted domain. So sine cannot be in this quadrant, right? So we're going to go like this. And sine's not going to be negative 1. Tangent will be negative 1. So what we're going to do here is we're going to look at this. So this is 0, 1. Oops. Hold on a second. We're going to look at this. And this is 0, 1, 1, 0, 0, negative 1. Where is sine negative 1 in its restricted domain? It's at negative pi over 2. So this is just another couple of examples. Where is sine a half? Sine is a half at 30 degrees or pi over 6, remember. First and fourth quadrant, that's it. So sine being a half, opposite over hypotenuse. Okay, we know that's 30 degrees. So you would say 30 degrees, or you would say pi over 6. Likewise, where is sine root 2 over 2? Also positive. First quadrant, 1, 1, square root of 2, right? Sine is opposite over hypotenuse. We're at 45 degrees, so you'd say at 45 degrees. Or you could say pi over 4. And keep in mind, sine here, from here to here, that's our restricted domain. A couple of things about understanding the restricted domain of inverse sine. Remember when you're trying to find an angle like this? Let's say we're trying to find theta. And here you are standing here. There you are. Opposite, let's do sine. So sine of theta is equal to opposite over hypotenuse, right? A over C. And so we know theta is equal to arc sine of A over C. Well, the question is would this value, if this was a right triangle, could this value ever be greater than 1? And what we're asking is basically we know the area for sine. See, if you drew a sine graph, here's my sine wave, right? High 1, down negative 1. See that? That's your range right here from negative 1 to 1, right? That's your high and low. So that means that in a inverse, that becomes my range that becomes my restricted domain. You can't have it outside of 1. It's always going to be less. So it's similar to what we're doing as far as the restricted functions to make in order for this to be 1 to 1. We have to restrict it. And so you have your 1 to 1 here, 1 to negative 1 here. You have negative pi over 2 to pi over 2. But when I reflect this across my y equals x axis, those values switch. So what I was saying earlier is for a regular sine wave, right, our domain is going to be from negative at pi over 2 to pi over 2 so that my function can be 1 to 1. And my range is going to be from negative 1 to 1. However, when I go y equals arc sine okay, of the value x, what ends up happening is that my domain becomes my range, and my range becomes my domain. And so basically everything's flipped. Okay. So here's a couple of composite problems that we can try. This is, and one of the things that I suggest to students is that you always work inside out. So that we're going to do the inside first and then work out. So this is saying, where is sine root 3 over 2? So let's draw our graph. We know we're in first or fourth quadrant. Root 3, so we can't be in this quadrant because that's negative, and this is positive. So root 3 over 2, opposite over hypotenuse, we are at a 60-degree angle, or pi over 3. So we know this value is the angle we're at is pi over 3. Well, the next question is saying, well, what's sine of pi over 3? Well, sine of pi over 3 is root 3 over 2. Okay, that's my answer. Now, that works just fine, and as all these do. However, they're not always going to work. Okay, let's do this one. Where is sine root 3 over 2? Sine is root 3 over 2. So we've got opposite over hypotenuse. So we've got opposite over hypotenuse. Well, right here, we have a problem because this shows that my hypotenuse is smaller than my leg, which is not going to work. So this one is no solution for that one. This one, though, says, where is cosine root 3 over 2? But remember, cosine has to be in the first and fourth quadrant. So and this is positive, so it can't be in the negative quadrant. So root 3 over 2, remember, cosine is adjacent over hypotenuse, which makes that 1, which makes that a 30-degree angle. So therefore, it's pi over 6. So we would say this part of this problem is pi over 6. Well, now they want to know what's cosine of pi over 6. Well, cosine of pi over 6 is root 3 over 2. Now, remember how I said this doesn't always work. Let me show you one that doesn't work. What about this? This is saying what is. Remember, if it's an arc, it's saying where, but that's a where. But this is a what. So they're saying, what is sine of 5 pi over 4? Well, this value right here is 1 1/4, right? So that's going like over 1 1/4, okay? So 1 1/4, I'm at sine, and we know that's a 45-degree reference because of the 4 at the denominator, okay? So we know that sine of this value is going to be root 2 over 2. However, all students take calculus. Sine in this quadrant is negative. So this is negative, okay? So now the question is, arc sine, where is sine negative root 2 over 2? So now what's happening is I am now restricted to this first and fourth quadrant. So this is saying, where is sine root 2 over 2? It's not here because this is negative. So I'm down here at negative 45 degrees, or at negative pi over 4. Okay, so we have some of these. I would suggest that you pause the video and start it again after you work some of these out. This is saying, what is sine of 2 pi over 3? So sine of 2 pi over 3 is here, right? 3 goes into 180 6 times, so 60 times, so there's 60. We know our answer is going to be root 3 over 2, so there's root 3 over 2, and this is arc sine. Now the problem again, remember that we are limited to first and fourth quadrant. When you see this arc, the inverse, that is only in first and fourth quadrant for sine. So in the first and fourth quadrant, right? In the first and fourth quadrant, we want to know from here to here, we want to know what sine. So it's positive, so it has to be in this first quadrant, okay? So where are we at in this first quadrant? At 60 degrees here. Well, that's going to be pi over 3, okay? The next one is saying, this says what? What is sine of 5 pi over 3? Well, 5 pi over 3 is 1 2/3. So let's draw that. So we have 1, here's 1 pi, and now we have 2/3. So we're 1/3 short. 3 goes into 180 60 times. That's a root 3 negative. That's a 2. That's a 1. So what is sine of 5 pi over 3? Okay, negative root 3 over 2. So this is negative root 3 over 2. And now I want to know, where is sine negative root 3 over 2. Well, it can't be at 5 pi over 3 because that would mean that I had to go all the way outside of my restricted area. Remember, this is it. If I said 5 pi over 3, I had to go outside of my restricted area, and you can't do that, okay? You have to get there to the shortest distance, which is from here to here, going down. So this value here has to be negative pi over 3, okay? This one says, this is a what, okay? That's a what. From here to here is a what. What is cosine of negative pi over 6? So negative pi over 6, okay? 6 goes into 180 30 times. That's a negative 30 degrees. That's our 1, negative 1, 2, square root of 3. So what's cosine? Cosine is root 3 over 2. So what it's saying is now we're saying, where is cosine root 3 over 2? Okay, where is cosine root 3 over 2? Now, remember, our restricted area is here to here for cosine, 0 to pi. And so where within this distance, this area right here, is cosine root 3 over 2. So this is positive, so that means that this is out because cosine is negative there. So in the first quadrant, we have root 3 over 2, right? Oops, I'm sorry, that's not right. Cosine being root 3 over, sorry, here, root 3 over 2. So where are we at? This is a 1, so we're at pi over 6. Done. 3 more. Inside out. So do these inside ones first. This is saying what is tangent of 11 pi over 6. So let's graph that first. So this is 1 and 5, 6, right? That is 1 and 5, 6. So let's draw that. So here you go. 1 and 5, 6. 6 goes into 180 30 times. We have a 30-degree reference. So that means that this is 1, 2, square root of 3. But remember, this is negative 1. So now it's saying, well, what is tangent of that? So tangent is opposite over adjacent. So this value here is negative 1 over root 3, right? So now it's asking me, where is tangent negative 1 over root 3? But remember, it has to be in this restricted space right here to here. So for me to get here, I have to go down to get there. I can't go outside. Okay, so now what ends up happening is I need to go negative pi over 6 to get down that way. Okay, inside out. So let's see, this is first. So what is cosine of 7 pi over 6? So 7 pi over 6 is 1 and a sixth. 6 goes into 180 30 times, so we have a 30-degree reference. So 1, 2, negative square root of 3. So what is cosine of that? It's negative root 3 over 2. So now they're asking me, where is cosine negative root 3 over 2? But remember, I am in this restricted area from here to here, 0 to pi, 0 to pi. And so what happens here from 0 to pi for cosine can't be here because that's all positive. So I must be here. And so where am I? With the 30-degree reference, 30 degrees goes into 180 6 times. So this distance here is pi over 6. So that means that distance from here to here is 5 pi over 6. Arc sine is the same thing as saying arc sine like that. So what this is saying is, where is sine 2 over 3? So it's a positive. Remember, sine is first and fourth quadrant. Where is sine? Where is sine 2 over 3? So that's got to be opposite over hypotenuse. So that's 9 minus 4, which is root 5. Okay. So where are we? We're here. So now this is saying what? What is cosine of where we are? Well, that's going to be root 5 over 3. Okay. So we have 6 more of these. So almost done. Where is cosine negative 1/2? So cosine is negative 1/2 in first to second quadrant. It's going to be over here in the second quadrant because it's negative. These are positive. So negative 1, 2, that's root 3, I'm at a 60-degree reference, which means this has got to be a pi over 3 from here to here, which means the distance from here to here is 2 pi over 3. Okay? This is saying, where is tangent? Negative root 3 over 3. And remember, this came from this. All right? And so where is tangent? Negative 1 over root 3. Tangent is first and fourth quadrant. So we've got opposite over adjacent. Okay, so where are we at? We're at a 30-degree reference going down. So it's going to be negative pi over 6. This is a little bit tricky because sine is only from negative pi down here to pi over 2. Negative pi over 2 to pi over 2. And if you think about it, pi is 3.14. Cut that in half. You're at 1.57. So this is 1.57. So where's 1.8? So 1.8 is like over here somewhere, which is out of our area. So this one has a no solution. The next ones are, let me roll that back up a little bit so you can see. The next one says what. This is a what. If it doesn't have an inverse, it's a what. If it has an inverse, it's a where. And whenever they say where, you're looking for an angle. So what is tangent of pi over 6? So pi over 6, 6 goes into 180 3 times. So it's a 30-degree reference, okay, which is 1, 2, square root of 3. So what is tangent? Tangent's 1 over square root of 3. Where is tangent 1 over root 3? Well, this one's perfect because we're already in the same quadrant. So it's at pi over 6. This one, though, says, what is sine of 3/4 pi? So remember, 3/4 is over here, and we have a 45-degree reference. Sine is going to be root 2 over 2. So what they're asking me now is, where is sine root 2 over 2? Well, you remember, don't forget when you're using an inverse, you have got to restrict your domain. So that means that this area is it. That's where I'm at. That's it. So where is sine root 2 over 2? It's in the first quadrant at 45 degrees, which is pi over 4. This one here is saying, where is tangent negative 1? So that's, again, restricted. Restrict it from here to here. You've got negative 1. It's got to be in not that quadrant. Down here, tangent opposite over adjacent, so negative 1 over 1. This is root 2. So where are you? You're here at negative pi, what is that? Negative pi over 4. No, yeah, negative pi over 4. And what's sine of negative pi over 4? So sine of negative pi over 4 is root 2 over 2. Oh, but this is actually negative, right? Okay, couple more. Find the following inverse functions if. So this one right here, arc sine 3 over 5. So let's plug this in. I think we just did something like this. So it is positive. Sine, this is my area. Sine is opposite over hypotenuse. This is a 3, 4, 5. What's cosine? So cosine is going to be equal to 4 over 5. Where is cosine? Root 2 over 2. So remember, cosine is first and fourth quadrant. So root 2 over 2, we're in the positive pi over 4. Right there, pi over 4. And what we know is, what's tangent of pi over 4? Tangent of pi over 4 is 1. So just go ahead and start, your homework. If you need extra help on that, please come see me. I hope this helps. Thanks for watching.